Now, if I remember correctly, I ended the last time we talked, last Wednesday, on, everybody see the screen? On hydrogenation, and I showed you how hydrogenation, oleic acid becomes stearic acid, and if I were to do this, most vegetable oils are highly unsaturated, so our oleal tells you there's a double bond in there. And I didn't have this example, but I'll do it now. If I react this with nickel and hydrogen, remember, in oleic acid, which is what this R is, there's a double bond. You lose the double bond, that becomes a sterile group. Saturated, S doesn't stand for saturated, it's sterile, which means this plus this is 18 carbons, only carbon-carbon single bond. Well, if I take the same thing here, what would be the product here? That becomes saturated, that becomes, therefore, what I get, if I put the right number of hydrogens, this. And what I've done is the double bond, which I showed you last Wednesday, is hydrogenated, becomes CH2CH2, which we show from that designation. And the question is, why do you do something like this? Well, vegetable oils, well, if it's an oil, it's a liquid at room temperature. Saturated fats, or in this case, this molecule, saturated, no double bonds, is a solid or semi-solid at room temperature. And if I put some yellow coloring, a little water, and a little flavoring, I can sell it as margarine, which I can get, instead of a couple dollars a gallon, I can get maybe $3 or $4 per quart, or even more, because the tubs aren't really a quart what you buy. And that's what the chemical or food companies did with vegetable oils, and that's how margarine became what it is. Many years ago, I worked for Unilever, which is Lever Brothers, and I was at a senior managers meeting up in upstate New York. It's a beautiful facility we're at, resort really. And this was before cell phones or anything like that, so it's a while ago. Shouldn't have said that. But anyways, and it was not just people like me from the chemical wing, but all divisions, including one poor soul, I don't know why his managers let him go there, he should have kept him home, started getting phone calls every half hour. And someone from the resort would come into our meeting, and so-and-so here, we have an urgent phone call. And after about 10 calls like that in a couple hours, the senior VP in charge of that looked at this guy and said, go back to your office. And what his problem was he was in charge of the marketing and sales for a new product Unilever was coming out with called, I Can't Believe It's Butter. And they were going to do a national rollout, which I don't know why they sent them here, but they're going to do a national rollout in a week or so, which means flood the whole United States with this product, which I don't know how many cases, I think 500,000 cases of it, and I don't know, 2,400 cases, to get to all the supermarkets in the United States. Well, someone opened up a case, opened up a package of, or a container of butter, pulled the top off and saw the foil was bulging like this. And they had 500,000 cases like that. Well, what was wrong? Well, they found out nothing really. I forgot the exact what was the problem, but how they solved it, they somehow were able to take it out, put it on a conveyor belt, and stick hypodermic needles in to get the gas out of there, and then sell it. True story. Anyways, that's hydrogenation. One thing I mentioned, but let's do this. on the test, give the organic product or products, and the question is tallow plus acid and water. And you look at that and say, what do I do? Well, if you remember, I talked about last Wednesday, tallow and yellow grease and white grease. I'm designating or using the following structure to approximate it, this. And what is this? A triglyceride. And you should know this reaction. Why? Because this is how your stomach breaks down fats and oils. What's the reaction? Ester. Which organic chemists write, or oil chemists write backwards. You all showed you knew this for test number 3. I just passed back. Ester, you get an alcohol plus the carboxylic acid you would have used to make that ester. Therefore, if I consume something with beef fat, which is really what tallow is, you should know tallow is beef fat, yellow grease, white grease, pig's fat. And here, first ester, we get this alcohol plus this carboxylic acid. Second ester, we get this alcohol plus what's my R group on the ester, R-sub-O for oleic acid. Now, what's the question I usually have on the test? Give the organic product or products. Now, last ester gives this alcohol, so you get glycerin. And finally, what would you get from the last ester? Stearic acid. So you don't have to, but you could put a 2 in front there, you could write it down again, like that, or oops, I made a mistake. This should be an O. So it happens when you rush. Slow down, all right, I will. And you could either write it like that, you could write this, or you could eliminate this and this, because this is a product, this is a product, that's a product. So you should know if I put down tallow, white grease, or yellow grease, this is the approximation what you should use through this reaction with acid and water, sodium hydroxide and water, or steam. Oh, that reminds me, when I was working at the company that did this reaction, similar ones, the president of the company called me into his office and said, no, we make a lot of glycerin and sell it. If we had kosher glycerin, we could make a lot more money. Can we make kosher glycerin? I said, no. Did I tell you that story? I don't think I did. And I said, no, because we use yellow grease and white grease. For those of you who don't know, kosher is the dietary laws for Jewish religion. And part of it is you should have nothing with pork in it. And when you're making something kosher, anything that whatever you're making touches should never be contaminated by things that are not kosher. Well, he said, are you sure? I said, I'll call up an organization, one of them, but I know I'm right. And I called them up. But you don't know, this is not going to be on test, but there's this, throughout the world, different organizations that certify things kosher. And there are a whole lot of symbols that, depending where you are, but probably the most common is the circle U, which means the Union of Orthodox Rabbi. A K is the Kira Society, and other parts of the country have different ones. And this tells you that whatever is made was made following the kosher rules, meaning certain things were never used. And usually what that means, at least in my mind, and I believe it, it's a higher purity. And to show you how it's gotten into just about everywhere, if I can find it. There it is hiding. If you look at the bottle here, by Please Recycle, there's a circle in U. That means this water, the bottle, and the bottle top is made under following kosher laws. And if you look at a lot of products in the supermarket, they're kosher. Just thought I'd let you know. And it turned out I was right, and I told the president, if we want kosher, we got to build a separate plant that only uses tallow that's kosher. And he said, no, we're not going to spend that money. And I knew that up front, but at least I found the answer to his question. All right, today and tomorrow, I'm going to teach you how to get clean. I bet you didn't think you'd learn that in my class, and that's how does soap work. Soap works by using what's called a surfactant. Surfactant is short for surface active agent. And as you know from the lab, Ian did it a while ago, surface active agents interact at the surface of things. And surfactants most surfactants can be ionic or cationic. There's a small group of non-ionic, but they usually have a polar head, non-polar tail. Non-polar tail usually is carbon and hydrogens. An example of that is a carboxylate anion of fatty acid. And these are used to make soap. Now if I look at this, I just have time to tease you. Tomorrow, this class will get